Yeah, so is it visible, my screen, all these things?
Yeah, your screen is visible and your slides are also now visible.
Yeah, okay. So thank you very much. Yeah, thank you. Okay. Yeah, so welcome to this session. So today that I'll talk about one of the applications of blockchain technologies. So mainly in the Internet of Things enabled drone applications. So therefore we'll discuss today what is the blockchain technologies in brief. Then I'll try to connect the blockchain technologies in one of the civilian applications known as the Internet of Drones applications. Okay. So therefore, the outline of the talk will be as follows. In the part one, we'll talk about a little bit of blockchain technologies and its potential applications. So this is also very important because though I'll go for very briefly blockchain technologies, but that what are the potential applications could be there in the blockchain technologies apart from traditional cryptocurrency as well as Bitcoin applications. Then in the second part, so I'll try to cover that one of the case study, so which is something known as the blockchain envisioned secure data delivery as well as collections mechanisms or 5G enabled Internet of Things enabled that Internet of Drones environment. So there that will show that it is possible to use the blockchain technologies in order to secure the data delivery as well as collections by the drones in the drone delivery systems. We can make the secure storage using the blockchain technologies. And once we are having data securely stored in the blockchain technologies, that we can do several other tasks. For example, we can do big data analytics in order to do better predictions of the data, etc. Okay. So therefore, let me to go very briefly about something known as the blockchain technologies and its various applications. Okay. So I guess that you know all about the blockchain technologies. Just for the sake of coverage of this topic, I'm just going through the very briefly, though it may be something redundant. So as we know that blockchain, so is a chain of blocks. So what is the block? Block is essentially contain digital informations. So therefore, the digital informations that created in terms of transactions in a block, and once we are having a block, that block needs to be mined in a special kind of network, which is known as the peer-to-peer that blockchain networks. So once that majority of the nodes in the P2P networks agree on adding that block in the blockchain, so then that block will be added in the local ledgers of each and every node in the network. And here that we are making a chain, so which is nothing but the cryptographically linked chain, because the hash of the previous block is linked also to the current block. So that's why that chain forms basically the cryptographically hash chain between the blocks. So as a result, if somebody tries to say modify a block, that attacker or intruder needs to modify the previous blocks hash values as well as the future blocks hash values. So which is impossible when your length of the block chain is very, very large. So as a result that we are having the digital informations which needs to be stored in forms of block, and it is linked in a chain form. So therefore the linked block constitute a chain. So that's why that we are having the name blockchain, means the chain of blocks, or a block will form the chain here. Then the questions come that the first created block in the blockchain will be some from the some point. So which has special name, something known as the genesis block. So therefore the genesis block will be the block which is the first block created in the blockchain. So now that one can tell that, so what is the difference between the simple linked list as well as blockchain technology here? So therefore in the simple linked list concept, so let me to turn also my camera, probably it is off, I guess, yeah, right. So in the simple linked list, so what will happen that the nodes, or say let them so it's also called as the blocks, they are basically also linked in a linked list. But in case of ordinary linked list, either it may be the single linked list, it may be the double linked list, or circular linked list, whatever is there. But there is a provision that even we say add a block or node in the chain or linked list, we can always update or delete or modify the data inside a node or block. And also there is a provision that at any point of time we can insert a block in the blockchain in the linked list, or even we can delete a node from the linked list also. But whereas in case of the blockchain, so once a block is decided to be added in the blockchain after mining process, or it is also known as the consensus mechanisms, that block cannot be deleted, cannot be modified, even no data inside the block can be also updated. So that's why the blockchain is also known as the immutable blockchain, means that the data inside the block in a blockchain cannot be tampered with that once the block is decided to be added in the blockchain. So therefore this is the major advantages of using blockchain as compared to the simple linked list. So what we have the linked list programs, etc., for so many applications, but that is the major difference with the linked list to the blockchain here. So then the questions come that why blockchain? So what are the major reasons that people will use blockchain? And of course that one of the things is that we should use the blockchain for the secure storage purpose, as compared to the we are having the say semi-trusted cloud environment. So what will happen that in the semi-trusted cloud environment, if we say store the data in the cloud, then there could be a possibility that a privileged insider attacker of the cloud server, for example, say admin fellow of the cloud server, can have provision to temper the data. Means that some data can be corrupted by the admin, some data also can be deleted, or inside the fake data in the cloud, etc., can be done here. But instead of that, using simple semi-trusted cloud server, and if we use the blockchain networks to store the same data, then one of the advantages is that the data, once it is put in the blockchain, that data cannot be tampered with that. So therefore, one of the advantage of this blockchain technology is that it is decentralized in nature. That means that even the same block is stored in each and every node in the P2P networks. Hence, we don't have any point of the single point failure case here. That means that even that in case of say cloud server environment, if the central cloud server say fails down, then the entire service will be hampered. But here in case of the blockchain technologies, even a node is down for some time of period, there will be other nodes in the network that can provide the service to the customer or to you. Okay, so that's why it is the decentralized in nature. Hence, there is no questions of the single point failure. Second thing is that data is cryptographically stored inside that. The meaning that, say, if we have the data to be kept securely, we can encrypt the data, and encrypted data can be put in the block, and that block can be mined and put in the blockchain. And even if, say, our data is not that encrypted, that means they're public data, even we are having the public data inside the block, but due to the cryptographic hash storage of previous block, etc., they are cryptographically linked. So therefore, in case of the blockchain technologies, an attacker cannot tamper with the data inside the blockchain, because if the data can be tampered with that, the hash of the block needs to be also changed, and which is impossible task when the blockchain length is large. And the next beautiful property of blockchain is that it is transparent in nature. So for example, say I have a block or I have transactions. Say I have put a transactions in a block, and that block was mined and put in the P2P network. Now after a certain period of time, after mining the block, the owner of the block, including anybody, can basically verify whether the transactions or block has been put correctly or not in the blockchain. So therefore, this type of transparency is there in case of the blockchain. So as a result, so what we are telling that we are having basically the three important pillars of blockchain technologies. So first pillar that here we are talking about as decentralizations. So decentralizations means that the information which is not stored by single entity or single node or single server in the network. And in fact, that everyone in the networks owns the information, meaning that everyone in the network also stored the same information or same block in the network. So second pillar is known as the transparency here. So meaning that it will add extra level of accountability, which is extremely needed by the biggest, say, institutions. Say, for example, if we are using, say, for say military applications, using for healthcare applications, we are using for banking applications, if we use the blockchain technology, and where all these things require the transparency. Then we are having something known as the immutability property. So by definitions, it means that once something has been entered in the blockchain, that information cannot be tampered at any cost. Okay. So therefore, once the block is decided by a set of majority of the P2P networks in the network, once the block is added in the networks, that block cannot be deleted, cannot be tampered with some fake informations, updating informations, deleting informations. Nothing is allowed in the blockchain. Okay. So therefore, the one of the reason, so why that blockchain gets so popularity due to the cryptographic hash functions. Now, as we look at the cryptographic hash functions definitions, so it is treated as a many-to-one functions. So meaning that there could be many inputs. Those inputs can map to the same output, which is known as the hash value or hash digest or message digest. So that means that, say, this is a many-to-one function. There are many inputs for which we can have the same output. Now, also the cryptographic hash functions is also known as the collision resistant hash functions, because if we say give you say output of the hash value, say, then from the hash value it is very difficult to retrieve or to determine what is the original input string for that hash value, because it is the many-to one functions. And that's why it is known as the one-way functions, one-way hash functions, as well as, so if an attacker tries to, say, for example, derive two inputs X and Y, for which the attacker needs to know whether there is a collision of these two input or not. That means that their hash values are same or not, which is very, very hard problem or impossible task problem. So that kind of functions, we are looking for that as a hash functions in cryptography. So that's why they are known as the cryptographic hash functions. So hence, by default, they are something known as the collision resistant one-way hash functions. So one of the example of collision resistant hash function is that something known as the secure hash algorithm, or known as the SHA. So we are having the variants of SHA algorithms. We are having the say SHA-1, so which takes any arbitrary length input but produces 160-bit hash output. So here is the blockchain technology uses SHA-256 hash algorithm, so which takes any arbitrary length input message but produces 256 hash output. So therefore, let us assume that blockchain uses SHA-256 hash algorithms, meaning that for any given input of length, any length, either whether it is 1 bit, whether it is 1 byte, whether it is a 100 bytes, 1000 bytes, but the hash output will be always of the same length of 256 bits. Okay. So if we take this example, first example, suppose we give the input as the high. And if we run this input on the SHA-256 hash algorithms, then we'll get the hash value as the 256 hash value, which is written in the hexadecimal format. So for example, in the next example, say for example, welcome to Block Greek. Glad to have here. If we give this input to this SHA-256, that's hash output will be like this. Now let us look at another interesting example here. Say for example, if I give the input as this is a test, and if we run SHA-256 hash algorithms, then hash output will be like this. And whereas that if we say, if attacker or you try to replace uppercase T by lowercase t here, but the meaning of the sentence is same, but you'll notice that the hash value will be completely distinct and different and random. So that is the one of the beautiful property of the cryptographic hash functions. So it means that a cryptographic hash functions is very, very sensitive even to a small perturbations in the input. That means that if there is even little difference in the input is there, but the hash output it is generating, it is completely random and distinct hash output. So therefore, as a result, in the blockchain technologies, if attacker tries to modify some data, say for example, this was the data, modifies even this data uppercase T to lowercase t, but the hash value will be completely different. And that will be detected when a block is verified using hash functions. So this is one of the reasons. So thanks to cryptographic hash functions, which provides, this is one of the very, very prominent property of the blockchain. So which is known as the immutability property. So next questions that I'll go to the little bit things because I need these things a little bit. So here that what we require that, so something known as the how to maintain blockchain nodes and networks. So blockchain is maintained by a special kind of network, so which is known as the peer-to-peer or P2P network. So what is the characteristic of the P2P network is that here all the nodes in the network, they are treated either equally privileged or equal privileged that functionality. That means that each and every node in the network, they can share the equal load in the network. That's why they are called either peer nodes. So in this network, what happens that suppose there is a node, this node, and if there is n number of nodes are there, that each node can communicate directly with all other nodes in the network. So as a result, so if we say take about this network as the undirected graph of n nodes, and it is the complete graph. So hence the number of edges or links will be nc2, that is n in minus 1 by 2 links or edges will be there in the network. So therefore, in this case, that each and every node can communicate with the remaining n minus 1 nodes in the networks. Okay. So as a result, in case of the P2P networks, so there is no longer concept of say one central server, and there will be several distributed servers, and they are decentralized, one of the decentralized peers. So here they can basically share the load of the network, and if one node say goes down, there will be other nodes to take care of the service to the customers. Okay. So based on that blockchain applications. So blockchain basically that categorized into the three types of that basically the three types. So first is known as the permissionless or public blockchain. So in this case, what happens that everyone in the networks will own the right to join, send, access, verify, or even receive the transactions of the blocks in order to create a consensus or agreement in the blockchain. So one of the widely that successful permissionless blockchain is known as the cryptocurrency or Bitcoin. Okay. So for example, say in the traditional banking system, say if Alice wants to send some money to the Bob, that Alice needs to send the money via some bank. Say for example, SBI is there, say HDFC, ICIC. So therefore, there is a trusted third party there, which is known as a bank. Via the bank money needs to be transacted. And of course, for each and every transactions, depending on the bank, there will be some commissions or transactions, say, uh, commissions that needs to be paid by the customer. But in case of the Bitcoin or cryptocurrency, so what happens that if Alice wants to send some money or dollar to the Bob without involving the bank, the Alice can directly send the dollar or bank in terms of say Bitcoin or cryptocurrency to the basically Bob. So there is no questions of here involvement of the bank, any other things. So due to this property, so Bitcoin or cryptocurrency is not so popular, specifically in India, because of these regimes and political regimes, because there is a trend that your all black money can be converted to the Bitcoin or cryptocurrency, and those cryptocurrency can be put in that market. Okay. So next is something known as the private or permissions blockchains. So here in case of what is the thing is that owner of the network that needs to decide, say which node to be assigned the right to access, send, say receive, join, as well as verify the block in order to create an agreement or consensus between the nodes in the P2P networks. So let us take one of the example of say private blockchain here, something known as the healthcare applications. So in the healthcare applications, if we look at a particular hospital, in the hospital we are having several kinds of data are there. We can have the patient related data, most of the things. Then we can have doctor informations. We can have say insurance information for the patients. We can have pharmacy. We have the something known as the laboratories. All these informations are there, and those informations basically very private as well as confidential. For example, there is a patient who is cancer patient, and those informations, private information, should not be revealed in public also. Therefore, what happens that each and every transactions related to a patient or related to any party or entity in the hospital, they are basically encrypted using the public key of basically the hospital authority or owner. So in that sense, the owner of the hospitals will basically own the information. So now the question is that, so in case of the hospital things, we can have a hospital networks or blockchain networks. For example, we can have say Apollo hospitals, we can have the care hospitals, we can have the say um, uh, Fortis hospital or something, AIMS hospital, all these things. If all the hospitals they form the blockchain networks, and or if all the informations pertaining to a each and every hospital they are put in the blockchain, therefore those informations of patients, everything, they are basically highly secure. And you can probably be aware of the one of the recent news is that that we had the news that the AIMS Delhi AIM hospital, all the informations they are basically hacked. So due to something known as the ransomware attack. So what is the ransomware attack is that if attacker able to compromise your say server where your all informations are stored, the attacker what will do, that attacker will encrypt all the informations using the public key of that basically, or using some say encryption key of the attacker. Then attacker will claim that okay, so I have hacked your say website. So they will just like say your in case of what is known as the uh, smuggling case, other things. So that attacker will demand that okay, so they demanded to AIMS that okay, to release the 200 crores rupees, then only they can give the key, and using that key, all the informations can be decrypted. So that's why the government of India also trying to develop so unified blockchain framework. So here also we are involved in the project from government, a national mission for blockchain technologies. So that project is something 65 crores project, uh, compromising of CDAX, IIT Hyderabad, Triple IT Hyderabad, and other forums. So to build a blockchain, national blockchain framework, so here all these data, including other data, can be also stored in the blockchain. Okay. So hence that is one of the necessary that if we can store in the blockchain our all secret informations, and due to blockchain inherent properties, the informations cannot be leaked. Even the ransomware attack, other attacks cannot be mounted in the blockchain also. Okay. So then that next one, so something is known as the consortium or hybrid that blockchain. So there could be a scenario. So here only one kind of blockchain, either public or private blockchain, cannot suffice in that case. So hence we require a hybrid or consortium blockchain where we can store the both types of data, private data as well as public data at the same time. Say for instance, say if we look at one of the scenario, for example, say intelligent transportation systems where majority of the informations are traffic related informations, where those are public data put in the blockchain. But there could be some private or private data. For example, if there is a high profile, say minister accident case is there, those informations cannot be put in the public. That data is private and put in the encrypted format in the blockchain. So therefore, there is a need for such kind of hybrid or consortium blockchain where we can put majority of the public data, but also we also require to store also the private data in the blockchain. So this is one of the example that I will cite here. So which is known as the how to form block in case of the public blockchain, private blockchain, as well as consortium blockchain. So just like your IP header, we are having the block header as well as block payload. So in case of the public blockchain, so for example, we are having the public header with the block versions, which is a unique serial number. We can have the previous block hash of the previous block. We have the Marklet root, that is something known as the Marklet tree is a special kind of balanced binary key, where the root contains the hash of all the transactions in the block that is stored in the block. Then we are having block type, either it is public, it is private, or hybrid or consortium. Then we are having something known as the timestamp, the time when the block was created, that is the block creations time. We are having the owner of the block. Then we are having the public key of the signer or owner. So here the public key will be used to verify the block signatures while a block is verified. So in case of the public blockchains, we are having the transactions in non-encrypted format, that is unencrypted. Transactions is transactions 1, transactions 2, and transactions NT. And all these transactions along with that block headers are used to compute something known as the current block hash. So current block hash is computed using SHA-256 algorithms on the fields pertaining to the block headers as well as block payloads. So once we are having block hash or current block hash, using the current block hash, we can basically create something known as the digital signature that we have already covered in the previous sessions, using the elliptic curve digital signature that algorithm. Okay. So hence that say for let us take this example. So suppose this block has been added in the blockchain. Then a verifier can, how the verifier will verify this block? The verifications of this block will take place at the 3 levels. One is the verifying the Marklet root, verifying the current block hash, then at last the verifying the signature of the block. And if all 3 conditions, verification conditions are valid, then one only treat a block as the valid one. Then it can take these transactions as the valid transactions. So it means that it guarantees that no transactions in the block have been modified, updated, or nothing. Now, if we look at the side by side in case of the private blockchain, so only the difference is that instead of here transactions in plain text format, we are putting the transactions in the encrypted format using the public key of the owner, block owner. So therefore, the transactions encrypted, and transactions encrypted. So once the encrypted transactions is there, on encrypted transactions, we will compute the Marklet root, then compute the current block hash, and on the current block hash, we will compute the digital signature using the elliptic curve digital signatures algorithm. And side by side, if we look at this here, so something known as the consortium blockchains. So in case of the consortium blockchains, what happens that, say, some of the informations can be encrypted, transactions can be encrypted, and majority of the transactions can be unencrypted format. So whatever way we are having these transactions, so then Marklet root will be created on these transactions. So once it is there, then we'll compute the hash of all these values to compute something known as the current block hash, CB hash. So once we are having the current block hash, then we can create the digital signatures on the block using the elliptic curve digital signatures algorithms known as the BSID. So therefore, this is a typical example. So having your transactions, how to create a public block, how to create private blockchain block, and how to create a consortium or hybrid block in the consortium blockchains. Okay. Okay. So meanwhile, any questions is there? Any questions? So do you have any questions? So okay, so thank you. So we'll continue. Okay. So now it is well understood. We are having transactions and we have created a block. So next question is that how to add that block in the P2P blockchain networks. Okay. So there is a popular algorithm, something known as the practical Byzantine fault tolerance algorithms, PBFT. So in this algorithm, say, let us assume that we are having say n number of P2P nodes in the network. Okay. So meaning that we are having say n number of P2P nodes in the network. And out of n number of P2P nodes in the network, suppose nth number of nodes are the faulty nodes, known as the Byzantine faulty nodes. So what is known as the faulty nodes is as follows. Say due to power failure, say some server say in India can go down. So that will be taken as a faulty node for some time. Or even a node can be say compromised or malfunctions, that could be taken as a faulty node in the network. So therefore you are telling that say let nth number of nodes be the faulty nodes out of total n number of nodes in the network. Okay. So in this algorithm, so what we require that we need a leader out of n nodes in the network. So therefore we require a leader selection algorithms. So that algorithms can select one of the node as the leader node, known as the minor node. Or even say for simplicity, we can use something known as the round robin policy algorithms to select say one by one nodes as the leader node. Say for example, we select this node as the leader node. And all other nodes, remaining nodes will be peer nodes. So then the leader node will have a block. Either it could be say private block, public block, or consortium block. Then what this leader node will do, the leader node will broadcast that block with a block addition request to all of the remaining nodes in the network. So in that sense, so what happens that all other nodes will receive the block. So then the peer nodes, what will do that they will verify the transactions inside the blocks using what are the things. It will use the market root verifications, it will do the current block verifications, it will verify the signatures. And if all verifications are valid, then what peer nodes will treat that block is a valid block. So hence that peer node, what will do that it will send back the valid reply message to the leader node. So the leader node will receive the valid reply message from its peer nodes. Okay. So let us assume that the leader node will maintain a counter known as the R count. That is the number of received vote count initially to 0. Now, for each and every valid reply message it is receiving from the peer node, this counter R counter is basically incremented by 1. Then the leader node will check if the R count exceeds a threshold value, something known as the 2NF plus 1, which is required for the PBFT consensus algorithms. So meaning that if the 2/3 of the nodes in the P2P network give the same reply that okay, valid your block, valid block, all these things, then only leader node will confirm that this block needs to be added in the blockchain. As a result, the leader node, what will do, that leader node will broadcast a commit message in the network, and after receiving the commit message, all other peer nodes also that insert the same block in their local ledgers. So in that way, that block is basically stored, same block is stored in all the peer nodes local ledgers. Okay. So this is something known as the practical Byzantine fault tolerance algorithms known as the PPFT. So apart from that, there is algorithms, popular algorithms, something known as the Ripple protocol consensus algorithms. So this is done by basically the company, so which is known as the Ripple US company. So it is also a voting based consensus algorithms. So for mining a block and adding the block in the P2P networks. And the Ripple company basically that funded that before 3-4 years for promoting blockchain as well as blockchain research, the 12 university in the world. And fortunately in India that there are 2 universities which got the Ripple funding. So one is known as the IIT Bombay, so they got the Ripple project funding. And fortunately that IIT Hyderabad also got the Ripple funding. So this is the second institution in India. So that's why in IIT Hyderabad we are also having a center, something known as the Center for Excellence in the Blockchain, which is also known as the Ripple Center for Blockchain in the Center of Excellence in Blockchain. And where also I am one of the active member in that blockchain centers. Okay. So in this protocol, so what happens that every participating node in the P2P networks will maintain a unique node list known as the UNL. So what happens in case of the RPCA that during the voting process, each participating node will constantly receive the transactions from its all peer nodes. Now your transactions will be basically checked for validity. If the transactions is valid, then it will be integrated to a set or list known as the candidate list. So after a certain period of time, that each participating node will dispatch its own candidate list to the other participating nodes as a proposal. So once the participating nodes receive the proposal containing the valid transactions, then what will do that nodes will the receiving node will check the whether the sender node belongs to its UNL list or not. And if it is so, then the node will verify the transactions with its own local candidates list set if they all are valid. And if the transactions get more than 50% of the vote, then the transactions will enter to the next round. And the next round will be called as the probing phase. In the probing phase, what that participating nodes will do, participating nodes needs to gain this board 50% to slowly 60%. And once it hits to the maximum threshold value of 80% of the board, then the node will decide that, okay, so these transactions can be added in a block and can be put in the block in the blockchain. Otherwise, so therefore, what we are telling that the participating node records the transactions confirmed by the 80% UNL nodes that needs to be added into its ledger data. And due to this mechanism is 80% of the voting mechanisms. So here that what is the threshold value is that is greater than equal to 5 NF plus 1. That is where NF is the Byzantine failure nodes in the network out of n number of nodes in the network. So then I am not going for other things because those slides are old. So proof of works, so it is a very old algorithm. It is very expensive because it requires to solve complex mathematical puzzles, which is very time consuming as well as power consuming. Then in 2017, that Ethereum switches POW to the POS, that is known as the proof of stake. So in order to mitigate the limitations found in the proof of work, that algorithms, in order to reduce significantly energy cost as well as processing time. So this is a typical example before going to the application. So what is that? Suppose in case of the Bitcoin, so someone say request for a transaction in terms of Bitcoin. So Bitcoin needs to be mined using some consensus algorithms. And once this algorithm say confirms this, okay, so this transaction is valid, then only the transactions will be put in a block in the blockchain and the transactions will be treated as the complete transactions. So that is how the Bitcoin or cryptocurrency basically works here. Okay, so then what is the thing is that, so due to less popularity of the Bitcoin as well as cryptocurrency, then researchers that found that why can't use blockchain technologies in several applications, starting from the civilian applications to military or other applications. Answer is yes. So researchers have successfully researched and they found that blockchain technologies can be a good candidate for several applications. For example, blockchain technologies can be used in smart manufacturing for better security purpose, can be used for the supply chain, can be used in the food industry, can be used in the Internet of Vehicles or Internet of Drones. Drones are also known as the unmanned aerial vehicles. It could be used in the healthcare applications. And finally, that it could be also used in the smart grid environment. And due to this nature of the blockchain technology used in the several other fields, then we are having now the new notions, something known as the blockchain of things. So it is just like your Internet of Things. We are having this notion, something known as the blockchain of things, where blockchain can be applied in several applications ranging from military to civilian applications. Okay. And if you are interested, so you can look some of the publications here in our research team. For example, we have applied say blockchain technologies in for mobile vehicle assisted precision agriculture's IoT networks, which was recently published in IEEE Transactions on Information Forensic Security, which is treated as the premier, the #1 security journals in the world. Okay. So then also we applied blockchain in vision secure data delivery and collection scheme for 5G based IoT enabled Internet of Things environment, which was published in IEEE Transactions on Vehicular Technologies. And these applications we are going to discuss in this session. And apart from that, it is possible to apply blockchain technologies in case of the supply chain. Also, that we applied blockchain technologies for Internet of Things deployment using access control mechanisms. It could be used for the IoT environment, as well as we have also used in the IoT enabled smart grid systems blockchain technologies to secure the smart grid that systems. Okay. So these are the some of the things, and apart from that, we are having several other works. So if you are interested, so you can have a look at it. And for any queries, anything, so please free to contact me in my email address listed here. Okay. So after this talk, I will also share the slides to the madam, so she can share the slides to you also. Okay, so this is all about something known as the, in brief, blockchain technologies and its various applications. Okay. Now, shortly, that we'll talk about one of the prominent case study in case of the IoT-enabled Internet of Things environment, where the blockchain technologies can be useful to secure data delivery and collections mechanisms for 5G based IoT based, that is Internet of Things environment. Okay. Yeah, so before that, up to this, so if we have any questions, all these things, so we can take some of the questions. Okay. Yeah, any questions, anything? Yeah, so my email address, I'm just typing here, ashok.das, equality.ac.in. Yeah, any other questions?
No questions are there, Professor Das. People are.
Yeah, then we can proceed, right?
Yeah, I think we can proceed. Yeah, thank you.
Okay, yeah, fine. Okay, so at last, so I'll try to give one of the case study where we have used in using blockchain technologies. And here that using the high level descriptions, and of course this paper is available in the IEEE Explorer. If you are really interested, so please go through this paper. For any doubt also you can just give me email all these things. But this is one of the very interesting works that where we have used blockchain technologies not only for secure storage purpose, and there this scheme also is one of the uh, very prominent, because using blockchain technology we can also uh, data delivery, collections, all these messages can be safely reached to the uh, something known as the GSS or downstream server, where the data could be stored in the blockchain, and for big data analytics those data will be very useful. Okay. And this work was published in IEEE Transactions on Vehicular Technologies. Uh, this is all this information. Now let me to give the very brief introductions of what is known as the Internet of Drones. So this is just like Internet of Things, where your drones treated as the things, they will be deployed in certain deployment area known as the flying zones. Then drones, they will communicate each other, and then the drones needs to communicate with their nearby something known as the ground station servers. Okay. And drones are also known as the unmanned uh, that aerial vehicles. So whose task is to control airspace and also provide support to various navigation activities. And in recent years, it has been seen that due to increase of the commercial drones applications, either it may be for the traffic monitoring systems, agriculture, that monitoring precision agriculture monitoring systems, and say parcel delivery systems, all these things. So they are widely now used in this commercial market. So hence, there is a big market of drones in the coming years. And it has been estimated that nearly 100 USD billion market opportunity will be there in the coming years based on the drone technologies. And due to popularity of the drone technologies, now there are several potential applications of the drones, ranging from the military to newspaper gathering. Say where say videography and photography are much difficult. Say for example, some extreme hill area where the accessibility of the vehicles, other things are very difficult. We can use the drones to make the videography and photography from the region for news gathering. It could be used for the security purpose, agriculture, logistic deployment. It could be used for also surveillance in the traffic monitoring systems, can be used for the medicine delivery, and so on. Okay. So now there is a question. So what is the need of the hour for secure data delivery and collections mechanisms. And it has been seen that in the recent years, so drone delivery systems is not new. It has been there in long time in London, where that people are permitted to exchange packages weighing up to 500 grams. Also that we are having the DHL delivery system, company, which also uses the drones to deliver emergency say items, for example, say medicines to remote areas. Now, so far that what was the trust that is used in the delivery system is that, say there is a service provider, they believe that their customers will not be repudiate the delivery confirmations after successfully delivering the items in proper destinations. So as well as there is a reverse trust among the customer, that customer needs to also trust that service provider will not deliver an item without presence of them, or deliver an item in front of the door is stolen. So that was the mutual trust. It was based on the drone delivery systems. But nowadays it is not uh, so easy, because this trust cannot be always true. So therefore there is a security requirements. For example, say confidentiality, authenticity, access control, non-reputations, etc. How that using these security services or requirements, we can provide the secure data delivery and collections mechanism, so that the customer can't deny that, okay, so don't say delivered some items in its absence, or say items are stolen. Because once the items are delivered by the drone will send the confirmations message to the service provider, so the service provider will be confirmed that your items have been delivered successfully by the drones. So meanwhile, there are several potential attacks are possible. One of the potential attacks, something known as the physical drone capture attack. Suppose a drone is flying some flying zones, some attacker can physically capture the drone, gets all the informations inside the drone, and using those informations, can adversary can capture other drones, etc. So that becomes a challenging task for developing a security mechanisms in case of the secure data delivery and collections scheme. And to address these things, we try to give a solutions for secure data delivery and collections mechanisms through blockchain technologies. So where your all the data that deliver between the drones and ground servers are secure, and then only the secure authenticated data, which is data delivery and collections data, can be put in the transactions will form the block, and block will be mined, then it will be put in the blockchain. So therefore it provides much better secure systems in such environments. So this is the typical the architectures that we have used in our proper schemes. So in this case, so suppose there is a registration authority trusted party whose task is to one time register to the control servers, and each control servers are in charge of a ground station servers and all the deployed zones. For example, let us take the precision agriculture applications, where a precision agriculture field can be say divided into several zones, and each zones will have say deployed, say dedicated some drones will be there. Drones can monitor that field. Also drone can be used to say give water in the field, or say spray some say jump skates, spray all these things for better that crops, other things. Okay. It can also monitor the conditions of the soil, conditions of the temperature, conditions of the weather, etc., to send to the remote that GSS. So then once that don'ts are deployed in applications. So don'ts will needs to communicate between them. Don'ts will collect informations, and don'ts also needs to send the information securely to the GSS, because the whatever data they sending to the GSS, they can be also tempered by adversary. So in case of the say don't data delivery and collection schemes, for example, your control room can instruct a GSS. GSS in turn instruct a DON to monitor some conditions, take some pictures, all these things, and sends the uh, data collections informations to the GSS, and those transactions will be from the blocks, and blocks will be mined that using a blockchain network consisting of the GSS that nodes. So later that your data, whatever put in the blockchain centers, they can be used for big data analytics. So big data analytics purpose is to use that machine learning algorithms, AI/ML algorithms. And one of the other paper that we had, so impact on probably that paper, you can also read that paper. So that is one of the interesting paper. So if you are interested, so that paper something known as the impact uh, on this one. So this is the paper. So the impact on blockchain-based AI/ML-based big data analytics for cognitive Internet of Things environment. So it was published in the Computer Communications Elsevier. There we have shown that if the data is put in the blockchain, and if we take the authentic blockchain data, and if we do the big data analytics using AI/ML-based algorithms, then your predictions, including your F1 score, uh, that accuracy, precision, and other things will be as accurate as compared to if we say put simply data in the cloud servers, and if the cloud servers data are corrupted by the data poisoning attacks, then there will be a great impact on the big data analytics. Your results, correct predictions will not be correct. As a result, the reputations of a company, say for example, say agriculture company, pharma company, that will go down significantly. So in this paper, we have shown that there is a huge impact if we use the blockchain-based authentic data for big data analytics as compared to the big data analytics on the data which are taken from the simple cloud server environment. And this is because that the heart of the machine learning algorithms is based on your uh, training data. If the training data is not genuine, and if the training data becomes poisonous, then whatever way you do the machine learning based algorithms, whether deep learning, predator learning, anything, that will not suffice your task, because your predictions, all these things will go significantly down. So that is one of the interesting that results that we put in this paper, that is on the impact on blockchain based AI/ML enabled big data analytics for cognitive Internet of Things environment. So you can go through this paper if you are interested. Okay, so again that I am going to the scheme very briefly with the high level things, because all other mathematical stuffs are there that may not be comfortable at this moment. So in our scheme, that we design a blockchain based secure data delivery and collection scheme known as the BSD2C IID, because it is developed in that Internet of Don'ts environment. So we are having the different phases. So the purpose of the system initialization phase is that to initialize the system related parameters, here we have used the elliptic curve based crypto systems, hash functions, all these things. Therefore, your registration authority will select collision resistant hash functions, for example, SHA-256 hash algorithms, elliptic non-singular elliptic curves, where you are having a base point, etc. Blah blah blah. Then registration authority private elliptic of based public private public key pairs. So once it is there in the registration page, your registration that basically authority will register all the control room, provide the credentials to them. Each control room they will generate their own private public key pairs. Then control room will be in charge of registering all the Gaussian server as well as all the drones. The necessary informations will be sent to them, and the credentials will be stored in the drone's memory prior to deployment in the target field. Then we are having the access control page, so whose purpose is to uh, deploy an access control mechanisms by which a drone and GSS can authenticate each other prior to delivering the sensitive informations from the drone to GSS as well as GSS to drone. Then we are having the secure data delivery and collections page, so which will be used to, so how does data delivery message can be securely delivered from control room to the GSS to the drone. And once the drones have the informations from the field, those informations that in terms of data collections informations, they need to also formed in terms of transactions, and transactions needs to be securely sent to the GSS nearby, that is known as the GSS Gaussian server. Okay. Then we are having, once we are having the transactions will be used to form a block. Then block needs to be added in the blockchain center using the, we have used the voting based PBFT algorithms, but we have designed our algorithms which is based on the PBFT algorithms to add the block in the blockchain. Then we had the dynamic drones addition page, because sometimes the drones can be physically compromised. Once a drone is physically compromised, then there may be a chance that attacker will use those informations, attack other drones. But the scheme was designed in such a way that the each and every drone will have their independent credentials, so that one drone capture will not hamper the security of the other drones that function with it. However, that if a drone say is physically compromised, that drone needs to be replaced by a new drone. So therefore, there is a question how to add a new drone in the network after the initial deployment of the drones in the client chains. So therefore, the proposed schemes will have 6 different phases by which these schemes basically works. So for instance, say this is the overall process. Though I'll not go through the schemes in detail. Some of the things I'll go. So for example, here the registration authority is there. So how the overall scheme is works as follows. So registration authority is there. So control room is there. Control room first send registration request message to the registration authority for registration purpose. Then after verifying the credentials, the registration authority will accept or deny the registrations, and if the registration is successful, it will send the registration's credentials to the control room. Then after that, control room will create its own private public key pairs. Of course, the elliptic of private public key pairs. So once it is done, so then the GSS downstream servers will send a registration request message to the control room. Control room will again accept or deny, and based on that, it will send the registration credentials. Then the downstream server, that will, what it will do, that it will generate the private public key pairs also, elliptic of private public key pairs. Then we are having the registrations of the drone in offline page. That means that the control room will generate private public key pairs of the drone, along with the other credentials on behalf of the drone, and those informations will be stored in the drone's memory that prior to deployment of the drone in the field. So let us assume that after registration, the drones are deployed in their respective, that is the zones. So then we are having something known as the access control phase between the drone as well as ground station server known as the GSS. So what would happen that, so we'll go through this page a little bit later. So through the exchange of the three messages. So first message is known as the access control request message, then access control respond message, then acknowledgement message. So through the exchange of the three messages, so the drone and GSS, they will basically that establish a session key between them. Then that session key will be used for exchanging the data securely between the drone and GSS. So that will be calling as the transactions. So therefore, once we are having the data securely collected by the ground station servers, it will create the transactions. Transactions may be that your from control room to GSS data delivery request message. It could be from say ground station server to drone to GSS. And once the transactions are created, then those transactions will be used to form a private block by the corresponding GSS. So once you are having a private block in the P2P GSS network, that a leader will be selected, and then leader will broadcast the block in the P2P networks using consensus algorithms. That block will be added. Same block will be added in the respective that GSS local ledgers. So in that way, that data, secure data is basically stored in the blockchain technology. So once we are having that data in the blockchain centers, that data can be now used for big data analytics using AIM algorithms later. So this is basically the mechanism. So I'll go again a little bit at high level because you can go through this paper. So this is based on something known as the certificate-based mechanisms. So meaning that registration authority first select elliptic curve, one hash functions. It will select the private public key pairs of the control room. Then it will also select that private public key for its own. And then it will create a certificate on behalf of control room, and the certificate is created using the private key of the array. So which means that the certificate can be only created by array, but no other fellow, including the control room, cannot create this certificate. So therefore, the forgery of the certificate cannot be done by anybody else. So once it is there, the control room will store these informations. After receiving these informations, then it will create its own master key and public key as follows, and it will store its master key and public key in its database. So in the next stage, that what control room will do, that control room will register the ground station servers using the elliptic curve based cryptographic algorithms. So control room will first pick its identity, pseudo identity will be created, then private public will be created, and those private will be used to create the certificate on behalf of the GSS. Then what GSS will do, that after receiving these informations, it will create its own private key, public key pairs, and then it will preload the information in its own memory. In a similar way, the registrations of drones, so in a flying zones by the control room will be done. So it will pick its identity, pseudo identity, private certificate, private key, public key pairs. Then it will create a private key, public key signature sketch, and also create that basically a certificate on behalf of the drone, each and every drone. Then these informations, pseudo identity, certificate, and uh, private public key pairs, so that is the signature private public key pairs, other things will be also stored in the drone's memory prior to deployment. Now then what we are telling that once the drones are deployed, drone and GSS, they can now execute the access control phase in order to establish a session key between them for their secure basically communications. So the in short, so what is there in this access control mechanisms? So for example, when the drone has its available information in memory, downstream has the available information in its database, then the drone will select a random secrets, randomly generated secrets, current timestamp. Then it will compute R prime, R1 prime using these informations, generate the signature, and the message will be delivered to the GSS containing pseudo identity. The purpose of pseudo identity is that we are not exchanging the real identity of the drone, so that attacker will not be able to know, identify who is the real basically drone. Okay. Then we are having this public key ADRI certificate stored in its memory, signature, created signature as well as timestamp. So after receiving this message, what the GSS will do, that it will verify the timestamp. If the timestamp verification is valid, that means that message is fresh, replay attack is not performed. So that was the sole reason behind using the timestamp in this case, to protect replay attacks. Then it will verify the certificate. Once the certificates are verified, it will verify the signature. Once the signature is verified, it will also create the random secrets R2, current timestamp, calculate R2 prime. Then defilement type key, it will be computed, session key will be computed, session key verifier will be computed. Then the message MSG2 containing the pseudo identity of the GSS, its own certificate, that is the public key, session key verifier, and timestamp will be forwarded to the drone. Then what drone will do? Drone will validate the timestamp TS2 and as well as the certificate by this verifications. It will verify the certificate. Now, if the timestamp and certificates are valid, then this message will be treated as the valid by the drone. Drone will then calculate the defilement type key. Then using the defilement type key, it will calculate the session key between the drone and GSS. Then it will compute the session key verifier. Then it will check whether the session key verifier is correct or not. And if it is so, then it will generate a timestamp TS3 and compute the acknowledgement of the session key, and it will be sent to the, in terms of message acknowledgement and timestamp, to the GSS. So finally, what GSS will do, that it will verify the timestamp, whether timestamp is valid or not. If timestamp is valid, it will compute the acknowledgement using the previously computed session key. And if both the acknowledgement are same, this acknowledgement and the send acknowledgement both are same, then it will ensure that both the party, drone and downstream server, they have created the same session key. And this session key will be now used for future secure communications between drone and downstream server. Okay. So this is the purpose of the access control phase. Now coming to this, uh, transactions. Okay. Now, what will happen that say several transactions can be created. Say, for example, we have taken the transactions here GSS request that it represents transactions between say control room and its GSS. So it will be treated as a data delivery request from control room to GSS. Then transactions can be of GSS DR request. It is a transactions between GSS and its drone. It denotes the data delivery request from GSS to drone in a particular flying zone. Then we can have that drone GSS response. It denotes the transactions between drone and GSS. It will be treated as the data delivery or collections response that from the drone to GSS. And finally, we can have the data that is captured by the drone, known as the transactions DR GSS data. So which will be treated as the transactions between GSS and drones, and it will treat as the collections message from the drone from the GSS to drone, all these things. Okay, so in a particular flying zone. So once these transactions are there, so the next task is to form something known as a block. And we have taken this is the private blockchain because data are private here. So therefore, we are having block header. Block header contains say block versions, previous block as Marklet road. Marklet road will be computed on the encrypted transactions here. Timestamp the generations of the creations of the times of the creation time of the block. Creator of the block here one of the GSS. Public key of the signer or GSS will be taken as the PK GSS. Then in the block payload, what happens that we are having encrypted transactions. So transactions could be of any one of the type. Suppose say there are n number of transactions are there. On the transactions we are encrypting using the public key of the GSS. Once the list is available, we can compute the current block hash on the hash of all the fields as well as encrypted transactions. Then signature of the current block hash will be taken using the elliptic of digital signatures algorithms. Now, once this block is created, then the uh, task comes that how to do the mining of that block in the P2P GSS networks. So in this case, that we have considered our own voting-based consensus algorithms that is rely on something known as the PBFT algorithms is as follows. Suppose that you have a block I, and NF GSS is the number of faulty GSS node out of a number of nodes in the network. So therefore, what will be the output commitment and additions of the block into the blockchain after successful validations? Say first step is that we'll first select the leader using some leader selections algorithms or random policy algorithms. Suppose GSSL treated as the leader, who has the block I to for mining purpose. Then what leader will do that leader will generate current timestamp for each council servers node GSSJ, performs the voting process, and for that purpose that leader node what will do that it will encrypt the voting request message along with the timestamp using its own using the public key of the GSSJ, and sends a message containing the block as well as encrypted voting request message. So once this message received by the GSS, that what GSS will do that GSS will decrypt this voting request message using its own private key. It will get the voting request message as well as timestamp. It will check the timestamp. If the timestamp is valid, then what it do that it will verify the block by means of verifying the market route, verifying the current blockers, verifying the signatures. And if all verifications takes place successfully, then what that PR node that is GSSJ will do, it will send a voting reply message and block verification status message as the voting request message, whatever is there, decrypted voting reply message, voting that is block verification status message, either valid or invalid, and all will be encrypted using the public key of the leader, and it will be sent to the leader. And note that this algorithm is different from other algorithms. Here, attacker cannot modify anything. So, because attacker does not have voting request message, timestamp, nothing is available to the attacker. So let us assume that V count denotes the valid voting request, uh, uh, basically the response message, and it is initialized by 0 by the leader. Now for each received response message from the uh, responder followers at GSSJ, so what that leader will do, that it will compute or it will decrypt this voting response message using its own private key. So using your private key, it will get the voting request message, voting the reply message, verifications status message. Then it will check whether it voting request message sent earlier is same as this message. Voting reply message was either valid or not. Voting block verification status is valid or not. If all are valid, then only it is going to increment the voting count by 1. And finally, it will check whether the voting count exceeds the PBFT, that threshold value 2 NF GSS plus 1 or not. And if it is so, then it will send the commit response message to all the follower nodes. And finally, the block I will be added in the blockchain into their local ledgers by each and every GSS nodes in the network. So in that way, the block is now added in the P2P GSS networks. Then we have shown that, so these are already illustrated in the proposed schemes. So the scheme is resistant to replay attack, manning the middle attack, drone or GSS impersonation attacks. For example, what is the impersonation attack is that, so on behalf of me, the attacker can initiate a message communications with the sender, receiver. But where I am not aware of this fact. So those kind of things are restricted here because of applications of the signature used in the message as well as the certificates used in the message. Then privilege insider attacker, so it is restricted because the privilege insider attacker cannot know basically all the private public keys of the entities. Okay. Then physical drone capture attack. So we have shown that even a drone is captured, only the drone's informations, if you look at the drone's informations, the drone informations is there. So these drone informations are distinct as well as unique for each and every drone, because for each and every drone, private public keys all are different. Therefore, even a drone is captured, those informations will not help to compromise other drones information, because those informations again are distinct. So in that way, the compromise of a drone does not lead to compromise of secure communications between other drones and GSS in the networks. Okay. So last that we are having something known as the ephemeral secret key attack, something known as the ESL attack. So this is very important attack in the security schemes. So what is the attack tells that? So we are have a stronger the threat model, something known as the CK adversary model. So under this model, what is suggested is that if the attacker can compromise a session state during a session, then the entity which generate the random secrets, all these things, those can be also compromised. And those compromised data, if it is used to compute in the session key only, then the compromise of a session will lead to compromise of the session key. But if we look at our schemes, so we have designed the scheme in such a way that the session key is computed using the something known as the that is temporal secrets or short-term secrets as well as long-term secrets. And due to that one, that even if the temporal secrets, random secrets are compromised, unless the permanent secrets, that means the KD or other things are compromised, attacker cannot compromise the session key of any drones. So even under the CK adversary model. So in that sense, the schemes basically offers stronger security as compared to the previous existing solutions. Okay. So then we have tested also using something known as the automated validations tool, which is the open source code, which is available in this Avispa project.org. But recently there is another good tool. Is there something known as the Cyther tool? SC. I'm writing that name Cyther tool. So you can have probably the note of this tool that is known as the Cyther. What is that? Cyther tool. So this is the Cyther tool. So this tool is nowadays very useful for testing what is known as the formal security validations of a security protocol. Okay. So then what we have done, that the whole protocol, access control protocol that we designed, we implemented using this Avispa tool, using a language available here, something known as the HLPSL language, known as the that is the high level protocols description language. So then we have seen that under this two backends, whatever available here, OFMC and CLATC. So what this does that, so once you are having a HLPSL language implementations, that will be translated using HLPSL to intermediate format to convert to the intermediate format code. Just like say for example, a C program is there, you compile using the C compiler, you got the A.output or assembler output file. The assembler output file, if you run it, you get the output. Just like that, you are having the intermediate format. If you feed the intermediate format to any one of the backend, so that will give the output format. So output format will precisely tell whether your scheme is safe or unsafe. If the scheme is unsafe, then this tool has the beautiful property that it will give the trace of the attack. So in which portions of the message the attacker has been able to change, how your big scheme becomes insecure, all these things it will be described very elaborately. Okay. Otherwise, that if it is safe, so the results will be like that, it is safe, and statistics, everything which will be given there. So next that we have done the test bed experiment for using the Miracle library under both the server setting as well as drone settings. In the server setting, that we have taken the server setting as the laptop here under the Ubuntu, that 18.0 LTS platform with the memory and these things. Then what we have done, that we have taken each and every primitive, for example, hash functions, modular exponentiations, elliptic curve point multiplications, elliptic curve point additions, bilinear pairing, all these operations. And then we have run each and every primitive 100 times. From the 100 runs, we have measured what is the maximum time, what is the minimum time, and then we have taken the average time for our comparisons. So like that, if you look at that bilinear pairing is very costly because it requires so much time. Whereas that if you look at the hash functions, also efficient, and elliptic curve point multiplications more costly than the elliptic curve additions. Now the same functions we have run under the something known the Raspberry Pi 3, which is taken as the drone that setting. Because Raspberry Pi, they are having resource constant devices. So what we have done, that we have coded each and every primitive, then put in the Raspberry Pi memory,
Raspberry Pi connected to a terminal. Then from the Raspberry Pi that we run that each and every that primitive 100 times. Then again we measured uh, maximum time, minimum time, then average time. Now, if you look at that in Raspberry Pi, that same bilinear pairing operations is very, very costly because it takes the 32.084 milliseconds as compared to the server setting here, because Raspberry Pi has resource constant. Even for the one hash functions time is more, where the under server setting time is less. So therefore, we have tested these things. So under the Raspberry Pi setting, treated as a drone. Under the server setting, treated as the laptop. Okay. Then we have compared that scheme with the state of art some solutions. The three solutions say Lua et al. Lua schemes, Lee scheme, Tian schemes. Then we have computed that how many messages sections are required and what is the total cost in terms of bits are required. Then we have seen that our scheme is significantly requires less cost as compared to other schemes, and we are having so much gain. And similarly, we also that use the average runtime cost for smart device known as the Raspberry Pi server setting. We have taken that laptop setting, the results, average results. We calculated that our scheme also performs better as well as comparable results with the TN schemes also. Then we compared that functionality and security attributes features with the Loyal scheme, Leaf, Tian scheme, etc. And we have seen that our scheme performs superior security in terms of security features. Also, the better that features, for example, supporting blockchain-based features, supporting dynamic donor device additions feature, and all these things. And it is seen that the scheme performs significantly better than the existing schemes, the state of art solutions in the time, so much better. And finally, that we have done some blockchain implementations. So blockchain implementation was done in the Node.js platform, which is a Java-based script platform. So here we have taken the two scenarios. So in the first scenario, what we have done that we have taken the number of P2P servers as the 5. We have created the virtual servers. Then we have taken the number of transactions per block as the 60. Then we mine, say, for example, 10 blocks, computed the computational time in second, 20 blocks, 30 blocks, 40 and 50 mine. So then we measured the basically the computational time required for the mining purpose using our consensus algorithms. Then we have seen that when the number of blocks mined are more, that requires more time, because when the number of blocks are more, it requires the broadcasting of the blocks among the peer nodes. Then block verifications times will be more, etc. And due to that, your computational time obviously will go up. And in the second scenario, what we have taken that number of P2P networks, number of nodes has fixed, but number of blocks we have fixed, mined as the 30. Then what we have done that we have vary the number of transactions per block. For example, if you take the only 25 transactions in a block, 50 transactions in a block, 75 and 100, then we see that computational time required for the mining purpose also increases slowly and linearly, because that when the number of blocks, say for example, are more, then you will see that so more number of transactions will lead to that verifications of the marketability road, current block as signature time will be also more. And due to that, your time also linearly that increases when the number of transactions in each block will be also that more. So that was the scenario that we used it. Then finally that it comes that, so can we have the real test bed, how the scheme is performing? So answer is yes. So in our lab, so we finally test our protocol, enter protocol using a test bed environment. So in the test bed environment, so we took that drone as a client. Constants are the GSS. We use the client server, that model for using socket programming, using Python 3 language. Then we configured that GSS as a laptop configurations. We take the Raspberry Pi 3 configurations as the drone. Then what we have done that in this case, uh, so so we have taken a drone. In the drone, we have installed a Raspberry Pi. In the Raspberry Pi memory, we have developed that our whole protocol here, and we put the code in this memory. And also GSS is there, their code of GSS also there. Then we have taken a cloud server in the lab, some desktop there, the data will be stored there. So we have created a local area networks, private networks using this router, where the GSS can connect to the router can connect to the what is known as the drone. So then what we have done that during the implementations, so we have seen that the drones, through the access control mechanisms, drone and GSS will exchange the data or messages. After that, they will establish the same session key here. So this is the 256-bit session key. 256 session key is there. And using the 256 session key as the key, we have used the AES 256 algorithms, advanced encryption standard algorithms for exchanging of the data. For example, say don't capture some image from some field. See, in our campus, so we say fly the drone in some area, capture the picture. That picture is stored in the say f2.jpg file. Then JPG file will be encrypted using the AES 256 using the session key, sent to the GSS, where GSS that receives the same file and decrypted and stored in the file. So therefore, this is well tested. So how this practically this protocol can be implemented for secure communications between drone as well as GSS. So therefore, this is very interesting work that not only we have done theoretical work, we did the blockchain simulations, we have done the test bed, though it is not scalable, but in future we want to do scalability of say 20 drones, other things at a time. So it is a significant contributions in this work. Okay. So therefore, as a result, so we discuss here something known as the blockchain technologies at various applications. As a result, our case study, we have discussed about a novel blockchain-based secure data delivery collection scheme. And that scheme not only provides access control between drones and flying zones, it provides the secure transactions gathering from drones to GSS and exchange of the drone to GSS to control domain, all these things. Then we applied the ECC-based signatures for and security depends on the elliptic digital signatures algorithms and collision-resistant one-hash functions. And it has been shown that the scheme achieves the significantly better security and it requires significantly low communication computational cost. So some of the future research work that AI-based big data analytics using blockchain would be one of the good research directions in this case, if you are interested for that one. So finally, these are some of the references there. So I'll also send the slides to Madam, so you can have this look on this. Okay. So thanks a lot. So of course, that if you have questions, we can have some discussions here.
Thank you, Professor. Questions, participants, if you have any questions, please feel free in asking. Raising your hand, we will be unmuting you. Yeah, it was such a wonderful session. In fact, starting from the very basic, you took us to the recent developments and research that your group is doing. We are thankful to you. And Neeraj Kumar is the person who is raising his hand. Neeraj, please unmute yourself and then
Thank you.
you can ask.
Thank
You
you.
also introduce where are you from? Yeah, thank you.
My name is Neeraj Kumar and I am a research scholar from NIT Hamipur. And
Yeah, you
my
can also
research.
switch on your video, okay? No issue.
Okay.
Neeraj, both your video, if you can tell so that we know to whom we are speaking and to whom Dr. Professor Das is answering.
Yes, ma'am. Yes,
yeah. That would be great. Speak a little aloud.
yes, ma'am. Ma'am, video on हुआ camera?
Well, we cannot see you, but okay, you please continue while you are.
Yes.
What is your question, Neeraj?
Yes, sir. Thank you, sir. First of all, sir, blockchain is a synchronized system or a asynchronous system?
For blockchain, right?
Yes, sir. Yes, sir.
So you are talking, it is for synchronized or?
Asynchronous. Sir, what
No.
type? Yes.
It is for synchronized because before putting the blocks in the blockchain,
Yes, sir.
all the nodes, majority of the nodes needs to be synchronized, right? Because they need to come with the common consensus before putting a block. So in that sense, it is asynchronous.
Means if blockchain is a public blockchain, then it is a asynchronous.
No, we are not talking about that. The one, any blockchain, either private, public, or consortium.
Okay.
But the question is that for mining a block, so the network needs to be synchronous because majority of the nodes needs to come with a consensus at the same time. Otherwise, you can't add a block in the blockchain.
Okay. Sir, actually, I am from mathematics department and I have no CS background. And my research area is cryptography, network security, and blockchain technology. So, what can I do for implementation part? Because I have little bit idea about.
So what I would suggest that so you can contact me.
Yes, sir.
So if you have any problem, we can discuss in offline, in Google Meet, other things. I have several collaborators around the world. So we can discuss that problem. Okay. And so we can do it.
Sir, basically, what have मतलब मुझे start कहाँ से करना चाहिए sir?
Yeah.
What is the starting process for blockchain implementation? Any little
Starting
bit idea?
process, because a starting process means that you need to know the code. For example, PBFT, Hyperledger sort of is there. So you need to know that how to code it, how to do the simulations of the blockchain. Of course, first under the small scalability platform, then to go to the high scalability platform, all these things. So that is necessary one of the things for blockchain technology, because you need to come to the blockchain simulations to show that how your scheme is scalable. Okay.
Thank you, sir. Thank you.
Yeah.
Any other person who would like to ask any questions? Okay, so